Okay, so here we are, again, factoring out the GCF of our binomial expressions. As you can see, we have some exponential terms here, right? Our x squared and our 3y squared. So now we're actually going to see a GCF that includes a variable and not just numbers. We might have both a variable and a number, or just a variable, but in this lesson we're not going to see just a number. So let's go ahead and look at this first problem. We have x squared plus x. We need to figure out what both terms have in common in order to factor out the GCF. So let's break this down a little more, just so you guys can visually see what's kind of going on here. Our x squared is x times x, right? Our x is x times 1. So when we break it down that way, now you can really see what each of them have in common. It's a single x, right? Only one of the x's though, not both of them. So we're going to factor out 1x, and then whatever's inside parentheses is whatever is left up here that we didn't factor out. So we have x times x is x squared. So we factored out our x, so that leaves us an x here, plus we factored out this x, so we have a 1 left. This is our factored form of our expression. We'll go ahead and check it real quick, just so you guys can check your own work sometimes if you're not sure. All you have to do is use the distributive property, so you're kind of doing it in an opposite direction, to see if we can get this to be the same as this expression, so where we started. So we have x times x gives us x squared plus x times 1, we get x. So I'll show those steps. And that's what we did, right? And this one matches up here above, right? So that's how you know your factored form is correct. And so in this case, our GCF was x. Okay, now let's take a look at our second problem. We have 3y squared minus 6y. So again, we'll break it down just to see kind of what's going on. We have 3 times y times y, and in this one we have 6 times y. Now, as you can see, they each have a y term, so we will be factoring that out, but there's also one more thing that we're going to factor out to get our greatest common factor. And that is actually going to be our 3, right? Because 3 also goes into 6. So we're able to factor out a y in both of them, and then we can factor out the 3, because 3 is also the greatest common factor of both our 3 and our 6. It's not our greatest common factor for 6, right? 6 is, but when we're looking at both of these, 3 is the greatest common factor for 3. So that's why we're going to go ahead and factor out 3 out of both terms. So if we take our 3y out, what do we have left in this first term? Just a y minus, and now in our second term, we're left with what? A 2, right? So we're going to recheck, or if you did recheck, you end up with 3y times y, 3y squared minus 6y, because 3y times 2 is 6y, so our greatest common factor was 3y, and this is our final factored expression of what we started with.